Hi everyone, I'm trying to create a quick little review video to help you with Excel, both getting the statistics that we calculated in Excel, but as well as making the graphs that we talked about today. So I just created a small sample set of data. I randomly or arbitrarily selected numbers. I have 3 categories. I have normal, high, and low. And then I have 18 trials. Over here I have what the pieces of information or the statistics I'm trying to calculate, and then I have sort of the cheat for how you calculate them there. Remember, with Excel, you don't necessarily have to write numbers over and over again if they are in sequential order. So if all I wrote was trial 1, I could highlight that cell, get the little box, and put my cursor on it, click and drag all the way down. Since this is set on fill series, it's going to fill it in numeric order. So that's what that is. If I wanted to copy it, I could simply hit copy cells and it would copy everything that I had in that original cell. So if I'm going to start with my normal column and I'm going to fill in these pieces of information. Whenever we want Excel to do work, we start by putting an equal sign. That's telling Excel it needs to do something. In this case, I want it to tell me how many samples are in my data set. Now, yeah, I could look here and say 18, but sometimes they're a bit bigger and a little harder to do that calculation. So I write the word count, open parentheses, and then I take my cursor and I click to highlight all the data sets in that column. Close the parentheses and hit enter. So 18, not a big surprise. Now I want to know what these data points add up to, the sum. In that case, I'm going to highlight the cell, hit enter, or enter equals, and whenever you hit that equals, some formulas will naturally appear up here. So I'm going to go and see if sum is one of them. It is, so I can hit sum, and then I'm telling it which numbers to actually do the summation with. So I say, okay, do these. Whoops, and I go back. I've selected them all. Now I'm telling it to go do something, and it figured them out. I can double check that if you're ever curious. You just highlight the number set you're looking at, and then usually at the bottom here on the right, Excel will show you the sum, it'll give you the count, and it'll even give you the average. So if you ever want to double check these real fast, that's a nice quick cheat to see what they are. So speaking of average, I go equal. The mean is, we use the term average to determine the mean here. Now I'm selecting my numbers. And again, I don't have to do it this way. I can write the word and do an open parenthesis. So for instance, for median, I will do that. Write equal, and then I write the word median, if I can spell, median. And then open parentheses, click and highlight the data. Close the parentheses, enter. So that is the most central point of that data set. Then if I go equals, and I write, come up here, highlight that box, go mode, open parentheses, close, enter. Now that is a number that most often appears. We talked about mode before. Unlike median, where if you have two numbers, an even number data set, so we would have had 9 and 9 in this case, 9 numbers on one side, 9 numbers on the other. You average the 2 in the center, that's why it's 12.5. With mode, you don't do that. If there was other numbers that were the same amount, you can see the number 7 is here 3 times. So if the number 8 was also 3 here, was also in this data set 3 times, I would just write 7, 8. You would write both numbers as the mode. Now I'm getting into ones that are a little bit more complex, that tell us a little bit more about variation within the data sample itself and how it can be applied to the population that we're looking at. So standard deviation of the sample, notice it's .s, that means sample. I'm going to hit equals. I'm going to come up here and I'm going to go stdv, dev dot, and see how the first one is .p, that's for population. I don't want that, I want .s. Open the parentheses, click the data sample, the data set, close it, enter. I'm going to figure out now the square root of my count or my sample size because I need that information to get the standard error of the mean. The standard error of the mean is the standard deviation of your sample divided by the square root of your sample size. So I need that square root of n. I'm going to create this formula by saying equals, and then I'm going to put SQRT, open parentheses, and now I'm going to go back to the n that I calculated and click that cell. Close the parentheses, hit enter. So that's my square root. For the next one, standard error of the mean, I'm going to actually do a formula. So I'm going to say equals. In this case, the formula is the standard deviation, which is that cell. And I do the division symbol, and then I select the cell that is the square root of n, and hit enter. So it's doing that math for me. Lastly, we don't typically plot the standard error of the mean. We plot two standard errors of the mean because two standard errors of the mean are representative of a 95% confidence interval. So I'm 95% sure anything within that range is something I could find within the normal population. So I'm going to do equals 2, and then I'm going to write times, which is the little asterisk, and I'm going to come to the cell right above it and hit enter. As long as all the numbers line up and are in the right order in the right place, to figure out the other two columns, I can highlight all of those cells at once and drag them across. So now I am getting the average for, if I highlight it, this data set. Or if I go next to it, I can say this is the average for the low data set. So you can see where they come into line up, come into play. To make a graph, I don't need all of this data. I'm not going to use my raw data at all, matter of fact. I'm going to use the descriptive data that I've figured out as descriptive statistics, things like the mean and the standard errors of the mean, or 2SEM, to be represented in my graph. So what I'm going to do is highlight my categories, because I want that on my x-axis. I want it to say normal, high, and low. And then I am going to hit the hold the control button down, and use my cursor to click and highlight the 3 average values that were found out, or the means. That's the bars that I want them to graph. I go to Insert, and I'm going to go to your traditional 2-dimensional bar graph. If I want to, I could be fancy and do that in the 3-dimensional one, but I don't really need that. So we're going to stick to the 2-dimensional one. I'm going to make my graph a little bigger so you can see it a little easier. I'm also going to change some aesthetics to make it more visible. So I'm going to right click on one of the bars, and now I can come in here and I can change the color and make them a yellow fill or an orange fill. I can make the outline, I don't know, green if I want to. You can kind of change some of those characteristics. The title is there. If I click on it, I can make a more descriptive title. I already have labels for the categories, normal, high, and low. And I already have my data on my y-axis scaled appropriately. So it's saying it in units of 5, and it's going all the way up to 40 to encompass the 38 that's here. So that's nice. Those type of things Excel does automatically. What it's not giving me automatically is the axis title for the x or the y axes. It doesn't automatically give me a legend to tell me what things mean. And it doesn't necessarily put in a heading or a piece of information that says I'm measuring standard deviation or I'm measuring standard error. So those are some things you have to go back in and add. And whenever you want to add, you go to the little plus. So I'm going to add in axes titles. And then I would have to come in here, click on this, and write what that title is, including the units. Same for the x-axis. I'm also going to come in here and say there's a legend. So maybe I want to say here that this yellow bar represents something. And then if I have a different color, it can represent something else, whatever you want to do. The big thing that we're going to do in this lab is put in error bars. So I'm not going to click on error bars because it will automatically default to a certain kind, but rather I want to use my data. So I'm going to go to the little arrow and come all the way down to more options. We want to use the I-beam figure. So this is going to be positive 2 standard errors of the mean, negative 2 standard errors of the mean. And I don't want it to do this fixed value, which is just part of an algorithm. I want it to do something that is specific to my data set. So I'm going to specify the value. I'm going to say what's positive error value. So I'm going to come here to my 2SEM, and click and highlight those three values. So it's going to take the mean of this and add 8 to it. So it'll go up to about 28.2-ish and so forth. But I also need to do the negative side. So I click that, come back to my 2SEM, highlight the same set of numbers, say that's the number set I want, and hit OK. And now it's put those 2 standard error of the mean bars in, or the 95% confidence interval. I can then analyze this graph. In the case of the normal data set compared to the high, this lower I-beam, the lower part of the standard error, is going to go beyond this whole set. So everything here, that whole standard error of the mean, would fit within the bars of this one. So there's no real significant difference between the two of them. It's the same for low and normal. The upper part of the positive 2 standard errors of the mean value goes across and pretty much just comes to where that one is. So if I want to be sure, I can insert a line. If you hit Shift when you click down, it'll be a straight line, and take it across. So I can see that that one and that one overlap. Because that overlap is there, we would say that there is a good chance they're from the same population, so they are not significantly different. But what I can say is different is between the high and the low. This standard error of the mean, or 95% confidence interval, does not overlap with this one. So we would say there is a significant difference between the high and the low categories. And then from there, you can continue on and do the t-test using your calculator to figure out what that p-value is between normal and high, and what it would be between high and low. I hope that helps. I will do one more video, I think, for p-value and the test statistic using a calculator, if I can figure out a way to record my calculator. So I will let you know if that works or not. Take care, guys. Bye.